Hello, my name is Mark Brakke from the Department of Animal Health and Welfare from Wageningen Livestock Research, and I will give a presentation, Why do semantic modeling of animal welfare, ontogeny, phylogeny, mechanism and function. This is a presentation for the online symposium Objectifying Animal Welfare, organized by the Friedrich Loeffler Institute. Nico Tinbergen got the Nobel Prize for his work on herring gulls, especially the red dot on the bill, and he showed how this was working in feeding the young chicks. Tinbergen also said that animal behavior can be explained in 4 different ways, answering 4 different why questions. Why the behavior is performed. You can explain its mechanism, so how one thing leads to another. You can explain it by referring to its function, so what it is good for. But you can also explain in terms of ontogeny, how it develops in the individual, and in terms of its phylogeny, how it evolved in evolution. And I will apply those 4 why questions to the human behavior, and particular human behavior, namely semantic modeling of animal welfare. Now, what is semantic modeling? Semantic modeling is a welfare assessment that is biological. It's based on biology and understanding, especially of the evolution of animals, how they evolved in a natural environment, and about logic, about using if-then rules to systematically derive a welfare score based on scientific information. I should note that semantic modeling, as it's used here, is different from its meaning in data science and using artificial intelligence to extract more about the meaning of, for example, databases. But semantic modeling is a method, a way to assess descriptively or objectively, if you like, the overall welfare state of an individual, an animal, a group of individuals over a period of time, which can be longer or shorter, in an assessment domain, like at system level or at a particular farm, or in a lab experiment, or the welfare of related to a particular enrichment material, for example. But expressing that overall welfare state on as a score on a scale, and usually use the scale from 0 to 10, and to do so in a formalized way. So using if-then rules and making the reasoning explicit based on scientific knowledge, so based on the meaning of scientific information, on scientific facts, but understanding it scientifically and using all scientific information that is available and that is relevant for assessing welfare. And then also it's important to realize that semantic modeling is aiming to improve decision making, and that is not always the case. Now, when it comes to the ontogeny of semantic modeling, it is how it developed in me as a person. I should look at my own early development. I am the son of a small farmer who gave up farming when I was very young. This is one of the rare pictures where I was herding a cow that was still having horns, so it's quite a time ago, but it got me, I guess, imprinted on farming. And I was asking why questions all the time. When I was a little bit older, I liked playing soccer and angling, but it is relevant, I think, to note that I liked fair play of soccer, but I really disliked unfair play. So that's why I didn't like to watch Dutch football on television. And I liked angling, but again, I did not like hurting the fish. Got me into trouble, and I did all kinds of things to solve that problem, which succeeded to a smaller or lesser extent. At high school, I was interested in philosophy, especially my Latin teacher, who was letting us read the Stoics like Seneca and Marcus Aurelius. And I was interested in applying the golden rule to animals. Don't do to others what you wouldn't want others to do to you, based on the logical idea that pain is pain. So if pain is wrong to do to one individual, it's similarly wrong to do it to another individual, unless there are morally relevant reasons to make a distinction between those individuals. At that time, I thought that killing animals and concern for the environment were not a problem for me. And I was wrong about the latter, but I still hold those views with respect to the former. And I loved kind of complicated teaching. We had a Greek teacher who liked to derive Greek and Latin words all the way to the original Sanskrit. That was quite complicated, but also mighty interesting stuff, at least from my point of view. Later at university, I studied veterinary medicine and philosophy in Utrecht. Also did a year in Florida, and I did a master's in applied ethology and welfare in Edinburgh, where I learned a lot about these subjects. In particular, in Gainesville, I was taught by Professor Hare, who taught me about the semantics of moral language, in particular the word ought. You ought to do something, what that means. There are descriptive and prescriptive elements in the meaning of a preference, for example. And later on, I worked for a couple of years as a practicing veterinarian, so I got some flavor of practices, how life was in reality for animals and farmers. And I then started my PhD at the institute in Wageningen called IMAG for mechanization and labor and buildings, technology, farm technology. And I got the job basically because a former colleague of mine mentioned that there was this vacancy, and as a kind of proverbial butterfly flapping its wings in the desert, it got me onto the semantic modeling storm. And as of 2001, so for quite a long time ago, I'm working at what was formerly known as the Institute of Animal Housing, Wageningen Livestock Research. My PhD is called Modeling of Animal Welfare, the development of a decision support system to assess the welfare status of pregnant sows. So pregnant sows were a case to develop my principles. When it comes to phylogeny, I'm thinking about how semantic modeling evolved in other people, and then of course the ancestral species is my promoter Jos Metz, who thought of the idea of trying to do something like that. But there are many others in the Netherlands, Karel ten Kate, who was letting me make endless hierarchical decompositions. Al Dijkhuizen showing me how to efficiently manage PhD students. Barry Sprout teaching me about the unconscious mechanisms of scientific debate. Gerrit van Putten telling me to stay true to myself, in particular my background in veterinary medicine, ethology, and philosophy. Willem Schouten teaching me about the relationship between production and stress, and that stress is costing energy. Professor Wiepkema with his Eastwit-Zolwit model of motivation, of course, and Herman Vermeer, who taught me about the history of group housing systems in the Netherlands, which were first adopted and then abandoned and then adopted again, and his role in doing research and advocating or explaining to farmers that it could work. And then there were the people, partly that I already mentioned, Professor Hare from Oxford, the Tiergerechtheitsindex and Bedarfsdeckung and Schadensvermeiding concepts from Germany, Professor Broom, who objectified and made animal welfare science a respectable science, Marion Dawkins and Ian Duncan for their emphasis on the feelings, and John Webster for his decomposition of the different needs. And of course, the Scientific Veterinary Committee for writing a decent review of the welfare of pregnant sows that I analyzed in detail for my PhD. And then in the future, there were semantic models made partly with me as an advisor, but also completely independent of my input, like my colleague Rudy de Mol, who worked on the Fowell model after I left the IMAG Institute, the group in Japan, and the group working on Yildiz et al. Working on sea bream in the Mediterranean. Now, these models that I know of concern the welfare of pregnant sows in housing systems, Fowell for laying hens, risk score for tail biting in the pigtail model, and model to assess the value of enrichment materials for pigs, fattening pigs in this case. A Cowell model to design better housing systems for dairy cattle, and a SWIM model for Atlantic salmon that Lars will be talking about later. And I did related work. I think the semantic modeling also could be very useful for assessing welfare in lab animal experiments, for example. And the work could also be used much better than it is today in assessing or monitoring on-farm welfare, as is done in the welfare quality project, for example. And I've been working on conceptual frameworks, in particular in relation to integrity and circular welfare economy, which I will not go into detail. When it comes to the mechanisms of semantic modeling, so how one thing leads to another, I think it's important to note that you cannot do it without money, motivation, time, and expertise. And with respect to expertise, you need to cover a lot of broad field. So you need to know about housing systems, about logic and if-then rules, and about science. So that's a kind of a wide and difficult for people who was into one field only. And then, of course, you need experts to provide input, basic facts and data, and perhaps also invalidation. Underlying the motivation to do it is the discrepancy between norm and reality, causing public debate, and also the discrepancy between how we keep animals now and in the past, and the need to underpin research, to underpin legislation by research. So then we have legislation that can be leading to proud farmers doing high welfare, working in high welfare systems, but it can also lead to scandals with a lack of integrity. Everybody knows, I guess, about the three concepts of welfare: feeling well, biological functioning, and natural living as defined by Fraser and co-workers. For me, the definition, conceptual definition of welfare relates to feeling well, but the biological functioning relates to the operational definition of how to measure and quantify it. Then we have the practical 5 freedoms and the more recent 5 domains model. I don't like the 5 domains model. Everybody likes it except me, I'm afraid. And there are different index systems, the animal needs index, the quantitative behavior analysis, and welfare quality, which is less formalized than semantic modeling. What I do like about the 5 domains model is the scale from very poor to very good welfare. My definition of animal welfare is the quality of life as perceived by the animal itself. So no matter how much what I think about welfare, what I want to assess is how it matters to the animal, not how I want the animal to behave. And then I use this Eastweird-Solweird model, which is originally from von Uxküll, but then adopted by Wipkema and modified again by me to also incorporate positive welfare states. Essentially, it says that in the evolutionary environment, the animal has, through evolution and through ontogeny, developed welfare needs that can be satisfied or frustrated based on the inputs from the environment, and it leads to behavior and physiological responses that essentially allow you to measure and that allow the animals to achieve its goals through positive and negative feedback loops. These different behavioral systems are related to one another, all supporting biological functioning. And of course, different between different species. And there are different ways to measure welfare and to load onto welfare, both in a negative and in a positive sense. Negative welfare indicators relate to measures of negative welfare in terms of pain and illness and death, reduced survival. Also stress measures and different behaviors like aggression, abnormal behavior, and frustration. But then there is also these positive indicators related to functioning in the natural environment, so natural behavior and species-specific behavior. Preferences in preference test and demand where animals are showing to work for certain resources, and how much they work for it indicates how positive it contributes to their welfare. Then this is a typical example of a scientific experiment where you provide pigs with different enrichment materials and find that the levels of tail biting also differ significantly. And if that is the case, that's the building block to start build a model with welfare indicators with different levels, where one level is significantly better than another, and that's the basis for modeling. And then you add different studies that compare different enrichment materials, and you can hierarchically make a rank from best to worst material. And you can put everything in a database where you describe a housing system based on its design criteria. And then in virtue of the scientific knowledge explaining the relationship between design and performance, you can also load the performance onto the housing system, and also, of course, directly observe how the animals perform in terms of welfare, and thus assess welfare, taking into account all the needs of the animal. Underlying prioritization rules for semantic modeling include that you weight environment-based design criteria on animal-based welfare performance criteria. Performance is weighted based on intensity, duration, and incidence. Those are important dimensions. Intensity relates to biological relevance, and you have to take into account all scientific knowledge and all welfare needs to assess overall welfare. And then it's important to be parsimonious, so not to make things more complicated than necessary. The Sowell model thus takes a description of a housing system as input, produces a welfare score as output, because it has collected all these scientific statements, which are decomposed into attributes or welfare indicators with their levels, and the distance between these levels are weighted because of the relationship between the different welfare measures. And then we have a weighted average calculation rule and a weighting based on the distance between the best and the worst level in terms of intensity, duration, and incidence. Now we can use empirical studies, which are costly and often not feasible, but we can also use expert opinion to validate the model. So I described different housing systems for pregnant sows and generated welfare scores, expert opinion scores for different housing systems, showing a very nice correlation between the model in stars and the box plots by the experts, 15 different housing systems, 34 different attributes. Some of them were also presented to the experts, and then the correlation is much lower. I will not go into the technical details of why this is, because it is, I think, a technicality. And the overall score, nicely shown by my colleague Rudy de Mol. The overall score, in this case of the laying hen Sowell model, is built up of component scores, and some components are more important than others, so they have a higher weight. And similarly, we made expert scores for broilers more recently, showing again that the more intensive systems, the less space per animal, the lower the welfare score, roughly. With other factors also contributing, we quantified that in the expert opinion scored here. And I did previously work on comparing different housing systems for calves, and again, more intensive systems, lower score, and also a difference between experts, which means that one or the other expert is wrong, because welfare is what matters to the animal itself, and it does not depend on the quality of the expert. Of course, you can be more or less right about it, but they cannot be both true. Interspecies comparisons in principle possible. Here I assessed provisionally the different welfare needs across different species, cattle, broilers, pigs, layers. I think we should also include humans to see where they are on this same scale, and then you would see, you would be impressed to the extent to which we value our own welfare compared to others. But I want to draw your attention to the cattle welfare in a recent study where we asked experts to compare the welfare of cattle living either in the beef industry directed at producing beef only, or in the dairy industry directed at producing both dairy and beef. And then we systematically see 70 experts internationally responded. And we find that there is a clear welfare reduction in the dairy industry compared to the beef industry. And this seems to result into a tension between what people normally do if they are concerned about welfare, because they first stop eating meat and then they stop dairy. So they continue to support financially the dairy industry, which is the lower welfare system compared to, at least for beef. And that is something that gives reason to think whether we make the best possible decisions. So now I come to the function of semantic modeling. What is it good for? I think it's good to assess welfare overall, not just of farm animals, but also other types of animals, lab animals, zoo animals, pets, humans even. It can be beneficial to improve decision making, make it more science-based and transparent, and also improve welfare based on that. And it can help solve welfare problems. So to help design better housing systems, I will show an example of a branch chain. There's even a method called intelligent natural design that I will not go into detail. But most importantly, I think semantic modeling is important, perhaps even necessary for sustainability. And there is a very important relationship to integrity. So coming back to the formalization of what semantic modeling is, it's a method to assess the welfare status in a formalized way based on science to improve decision making. And when you realize that you are optimizing, so not just assessing it, but trying to make the best possible welfare score for all sentient beings involved over a longer period of time and over a wider assessment domain, say an entire sector, then you're talking about sustainability. And when you are talking about making the assessment transparent, being open and honest about the welfare score that you do achieve, not leaving away any facts or not using fake facts, and really having the motivation to improve the decision making, then you're showing integrity. So you're being open and honest. And I will give a counterexample or showing how important it is. The rich pig model was used to justify fake enrichment based on a lack of human integrity. In 2001, the EC directive was issued saying that by 2003, a short chain was no longer acceptable. The ministry waited until 2003 to commission research, which allowed the pig sector to wait for another 4 years before it had to do anything. The model was finished in 2007. The farmers responded by saying it was too costly, and they commissioned another research, postponing implementation even further. The ministry drew the lowest possible line. The sector invented an even lower welfare solution by way of an anti-bite ball, a hockey ball attached to the end of the chain, which was effectively not adding a piece of plastic to a chain, but replacing the end of the chain by the ball. And that resulted in the fact, in my perception, that the rich pig model was used to justify a reduction of welfare, which was in fact illegal because the legislation intended to have an improved welfare status. So here you see in the middle of the middle picture a short chain, which was the conventional enrichment. If you add a ball to the end of the chain, you see these balls collecting dust. Pigs don't like it. Farmers who did not have a ball in their barn appreciated the value of the ball much higher than as soon as they got the ball in their barn, because they would immediately see it was not working. But they had invested millions in total and deprived pigs of millions of welfare points. And there was a cheap alternative, namely a long chain with branches that would have improved welfare much better. It took until 2019 when we showed this in expert opinion study. The orange columns show the short chain. The anti-bite ball attached to the end of the chain leads to a reduction in welfare, and the brown chain would have considerably improved welfare if it had been implemented. But due to a lack of integrity, it wasn't. So why do semantic modeling of animal welfare? I think it's important to remember that it is biological. It's about logic and about the biology of the animal. It is, in my view, the best possible science-based overall welfare assessment, and it is necessary for a sustainable future based on human integrity. That ends my presentation. Thank you for your attention. In the next slide, you can find the references, and they are there only if you have a photographic memory or if you check this video online. Thanks again for your attention.